Now in class 12th, I will tell you how the magnetic field vary on the axis of the current carrying circular coil. I have told you about the expression for the magnetic field on the axis of the circular coil. So magnetic field on the axis of current carrying circular coil. This B equal to mu naught Ni A square upon 2 A square plus X square raised to power 3 by 2. This we know. This we know. Now here we take the B and here we take the X on this side and X on this side. On the both sides, this is now positive, this is now negative. So the magnetic field is like this. This is your A by 2, this is minus A by 2. This is now point P1 and this is now point P2. This is not so much. This shows the variation. This magnetic field at this point, this is now your B naught. This is B naught. At the center of coil. This B naught equal to mu naught Ni upon 2. It is the maximum magnetic field. Maximum magnetic field. Maximum magnetic field. So this is at this point where this X is equal to 0. Now at X equal to plus minus A by 2. Plus minus A by 2. This we have seen. B equal to 0.716 into B naught. This we know it. But as we go away from this distance, for X greater, very greater than A, then we are having this B equal to mu naught Ni A square upon 2X cube. So now what we see? That at these points P1 and P2, these are called the point of inflection. At points P1 and P2, this dV upon dx is equal to constant and d2b upon dx square, this is equal to 0. It means that at the points above the point P1 and P2, the magnetic field varies linearly. At points above P1 and P2, the magnetic field varies linearly, but at points below P1 and P2, the magnetic field varies rapidly. So what you can see that at this point P1 and P2, that this magnetic field and this magnetic field is linear, but this magnetic field and this magnetic field is not linear. Rather it follows the x-q law. So this B proportional to 1 upon x-q. The points P1 and P2 are called points of inflection. Points of inflection, and the distance between these 2 points you can see. Distance between P1 and P2, this is equal to A by 2 plus A by 2, so this is equal to A, the radius of so this is the radius of the coil. So these points are situated on both sides of the coil. So here you can see that this condition, this plus minus A by 2 will come out from these points. dV upon dx, that is equal to now constant. So we can have B equal to, now this is given to you now B. So d upon dx into mu naught n I a square upon 2 a square plus x square, this raised to power 3 by 2, this is equal to constant. So now you can have to this is now d upon dx. If you have a little calculation to this one, it will come out to be mu naught n I a square upon 2 bracket a square plus x square raised to power 5 by 2 into this scenario 3 by 2 into 2x, this is now equal to constant. So what we have, this 2 and 2 will cancel. So So this is now your 3 by 2 mu naught n I a square into x upon, this is now your a square plus x square raised to power 5 by 2. This is equal to constant. What does it mean? That if we further differentiate to this one, then this will lead to these terms x equal to plus minus a by 2 according to this one. So now d2b upon dx square, this is equal to 0. So now again you differentiate to this, then we will have this d upon dx into dv upon dx. This is now equal to 0. So now this d upon dx and this is now your 3 by 2 mu naught with a minus sign, so we leave this minus sign here. If you do it, then no change. Mu naught n I a square x upon, this is now your a square plus x square raised to power 5 by 2. This is equal to 0. So if you differentiate to this one and make it to be equal to 0, then you can find it gives what? A equal to this x equal to plus minus a by 2. So this is what? That the inflection points P1 and P2 are at a distance of a by 2 from the center of the coil. It shows that magnetic field on both sides of coil up to distance a by 2 is linear. So such points are called the inflection point that I have told you earlier. So this is what the variation of the magnetic field on the axis of the circular coil. On this basis, the Helmholtz scientists made the two coils. By means of them, we can produce the uniform magnetic field. So these coil are called the Helmholtz coil based on the name of the scientist. So that I will tell you in the next chapter, in the next topic. So this gives you that up to this point, up to this the a by 2, the magnetic field is linear. So this is the variation of the magnetic field. Thank you very much.